Sorry.
It's an immense pleasure and honor to have with us David Wolpert, who could tell us about very many different enriching living histories. I'm curious to hear which selection we'll hear today. It's yours, David.
Okay, thank you, Shri. Yeah, I suppose I've lived through a bunch of them. Um, like I expect many of the other speakers, I feel a little bit awkward talking about myself rather than talking about my science. We all want to talk about our own science, and nobody else should talk. We are the most important, brilliant scientists. Everybody listen to me. But no, I don't want to talk about me. But in any case, be that as it may, I wasn't sure exactly what might be most useful for this audience. So I'm just going to go over my sort of trajectory. I would not recommend this to anybody. In fact, when I do give advice to young people, I say, don't try to do this. This is career death. But for whatever reasons, I got very, very lucky. A meta comment is that a necessary, though not sufficient condition to be a successful scientist is you have to be really full of yourself and think you're brilliant. But in addition to our all being so stupendously smart, one thing I'm very much aware of is just how fortunate I am, just how lucky I am in my life circumstances. I live to work. It's my everything. The idea, for me, retirement would equal death. And also how lucky we are compared to other parts of the world. And in any case, if I convey nothing else, let that be there. Um, so starting way back in the day when I was a freshman, oh, David's there. Hey, David. Um, so when David was a freshman, when I was a freshman, different David, I had for what it's worth, I had a choice. Do I want to go into math? Do I want to go to physics? Do I want to go creative writing? Realized I was drawn very much to the short form. And so, oops, creative writing is off the table. I'm kind of like what Georgia, I guess, was saying, something sort of similar concerning music, comparative advantage. Between math and physics, I actually found it to be a strange phenomenon. I still look up to pure mathematicians. I view them as in some ways superior intellects. And what I could never understand is that many of the pure mathematicians that I knew at the time, they couldn't solve the physics homeworks perfectly. I couldn't solve the math homeworks perfectly, but I could solve the physics ones. So for whatever reason, that kind of decided things, and I was off into physics. Fine, well and good. Okay, got my undergraduate degree. I took a year off. I was running the computers at what was called the Rockefeller University Neurosciences Institute, a place that was at the time run by Jerry Edelman. One can recount many stories about him. But in any case, that's not what I'm here for. While I was there, as an undergrad, I had come to the conclusion symbolic AI is a complete obvious disaster, catastrophe. It's a failure. Let's just say that. It's not going to work. But then I started to think about, well, there might be other kinds of approaches. I was thinking mostly at the time geometrically, actually in terms of graphical approaches for trying to make progress on artificial intelligence. So I played around with what I was calling the heuristic binary engine, Herbie. And this was way back, and this was a field that would eventually become known as machine learning. But at the time, no way I could find anything about that in the literature, so I was just off playing by myself. I had to make the decision of whether to return to academia to grad school or to stay out. For me personally, there was a big overhead returning into physics. All of a sudden, for me, an independent adult human being, I was going to have to spend this year relearning for the nth time Jackson electromagnetism and having these annoying TAs who are giving me X's for one of the problems I do in a problem set every single week. And I'm supposed to care about this kind of a thing. So it was kind of tough on me personally, but whatever, got through it, passed my quals. I was working then with Jim Hartle, quantum gravity. And that was fascinating. But after 1 year of that, I happened to have my ear to the ground. There were 50 PhDs that year one postdoc opening. Yeah, sure, I'm smart, but those are not good odds, especially given that the people who are graduating in quantum gravity, those are really smart people. Well, fortunately, at the time, this was when physicists were starting to get interested in what was now called neural nets, models of the brain, they were thinking of it as, and things like this. And I had this stuff about machine learning. I kind of faked my way through it and got a PhD in 3 years in physics, doing what essentially was, in some cases, discovering for the first time, in some cases, rediscovering a bunch of techniques that we now call machine learning. Close to the end of my last year, I saw a talk by at the Calvi Institute for Theoretical Physics. It's now called. That's where I was, by Doan Farmer. You can read about him online. An extremely colorful figure. We hit it off. He got me interested in coming to be a postdoc. So I was then a postdoc in his group at Los Alamos, which other people who were there involved with artificial life, for example, fellow postdocs were Walter Fontana, Steen Rasmussen. It was that kind of a world. And I then got a postdoc also at the Santa Fe Institute after that. Now came a very unpleasant experience. I encountered one too many talks, being someone who was doing what was now called machine learning, where people said my algorithm, be it in supervised learning, in optimization, what have you, my algorithm, I can prove mathematically that's superior to other algorithms in general without making any assumptions. This had struck me always as ipso facto. Obviously, that can't be. So I and a collaborator, Bill McCready, we just put together some mathematical proofs of that, thought it was trivial, popped them out into the literature, time to move on. It didn't torpedo my career, but it came very close. I'm a postdoc at the time, and I am going to conferences where the keynote speaker starts by saying, David Wolpert is a Neanderthal. He has set the field back by 5 years. The response of people was vicious because without realizing what I was doing, I was basically bursting a whole bunch of people's PR for why they are the next great thing. I concluded, that's it, I'm out of here. I thought that naively that the business world might have their money talks, so it would be less about bandwagons and that kind of a thing. I was being recruited by IBM Almaden at the time. So I thought, okay, let me just go there. This is it. I'm out of academia. I'm running a research group, but it's not in an academic setting. Then, while I was at IBM, I realized the way that I phrase it always is I learned what does and does not boil my water. And being the head of a research group, being a head of with a lot of direct reports and making a lot of money, I didn't care at all. I wanted more freedom. So I left IBM. I went to NASA Ames. I was now doing very different kinds of things: distributed control, distributed optimization, game theory. I did a lot of work in game theory. This was all a long way from quantum gravity. I also joined the Stanford Aerospace and Aeronautics Department. Me and my students were running a bunch of drones and constellations over the campus of Stanford way back in the day. So that was all a lot of fun. But let's see, how do I now move forward on this? No, that doesn't want to work.
Click on the mouse, David.
Click on the mouse. Oh, there we go. Okay, right, click on the mouse. No, wait, that's the wrong one. Click there. Okay. So, but I kind of got stuck. NASA. One thing so I've only got 54 seconds. Okay, so let me go quickly through this. Luck, as the phrase goes, it's the residue of design. It comes to, those who are prepared, etc. Favors a prepared mind. There was a guy called Misha Chertkov, who was also back at Los Alamos. He had a visit to Stanford. He was very interested in game theory. Game theory was very hot at the time. So he recruited me to become what's called the Ulam Scholar, the Stanislav Ulam Scholar back at Los Alamos. So I jumped again. I'm back at Los Alamos. I was brought into, after being the Ulam Scholar, then I just left out NASA entirely to become hired there. Supposed to start the machine learning effort. I was half-time at the Santa Fe Institute. Eventually decided that I thought that machine learning is frankly kind of boring. Back in the early days, when you go to conferences like Snowbird and the early ones, revolution had been in the air. We were going to be discovering these really deep principles. But now it's all really just a bunch of try this, see if it works, try that, see if it works. So anyway, left machine learning, left game theory. Here are some of the fields I went into. One thing that might be of interest to this audience was when I was working on other things, I stumbled across a field that's called stochastic thermodynamics, which is basically a revolution in non-Euclidean statistical physics. That entire field didn't exist really until the 21st century. Major revolutions, we can do amazing mass. These other people figured out how to do extraordinarily important things. David Sivek can be talking about this, that are of direct relevance and should be of direct interest to all of biology, computer science theory, a whole bunch of things. I realized, having bounced around many different fields, that there's no way the people in computer science were going to all of a sudden say, oh, what you thought you knew about thermodynamics of computation, it's wrong. Replace it with stochastic thermodynamics. That wasn't going to happen. And the people in stochastic thermodynamics, they were not going to be interested in computation. So I knew that I would just be beaten up for about a decade trying to pull those fields together, but there was no way that this could fail in the end, so long as I kept at it. No skill was needed by me, but just a dogged persistence. Kept at it, and this field is now starting to actually hit, starting to get legs. There's a PNAS perspective article actually on this just a couple of weeks ago, if anybody's interested. And these are just some of the things that, oops, there shouldn't be an S there. These are just some of the things that I'm currently working on. 2 or 3 projects on the very foundations of math. Computer science theory. These are some of the amazing things, the proverbial low-hanging fruit. Many, many fields like social systems. You will hear many, many people say social systems are computers. Many people in biology will say biology are computers. You ask them, what do you mean by that? Give me a formal definition. What are the properties of computers that you are exploiting or investigating? Raging silence. But guess what? There's this field over there in the next building on campus that all that they are about is understanding what computation is and how it can be implemented based upon various resource constraints and so on. It's computer science theory. So a lot of what I'm doing now is just taking computer science theory, porting it over to all kinds of social systems modeling, deep history. There are other people I'm working with where we're looking at microbiology and maybe even we're looking at natural selection itself as a computer. I'm also, people may have heard about what's called the simulation hypothesis, the idea that we are a simulation in a computer. Well, guess what? As I just described, the simulation hypothesis, the Matrix movie, it's about computers. How many people have ever actually investigated the computer science theory of the simulation hypothesis? Empty set. It's just, it's very, very easy in a certain sense to be somebody who can recognize deeply rich topics in science just by keeping your eyes open. Whether you can make a career out of it is a completely different issue. So I'm working with Carlo Rovelli and others, thermodynamic arrow of time, et cetera, et cetera, et cetera. I think I'm probably substantially over. So for what it's worth, there you go. That's my bing bang through a pinball machine of different fields.
Thank you so much, David. On behalf of the audience, I'm clapping. Thank you so much for this wonderfully entertaining and inspiring talk. In the interest of time, I will take one question from me, which is the following. It's a serious question, which is that you described the the hostility, the unanticipated hostility
Oh yeah.
that you experienced after writing what was, as you put it, perceived as a paper that ended lots of busy activity rather than creating lots of busy activity.
Hmm.
With the benefit of hindsight, would you do it again? Do you recommend to people who are in the Matrix generation that they should try it?
Oh no, that's an interesting question. It was actually several papers, and among other things, I view them as some of my most trivial work, but it's actually the most cited. Um, that gets a lot to purpose in life, whether my purpose in life is to make existence good for me or to try to actually add my fractions of a penny to the human enterprise in the broadest sense. If the latter is the answer, yep, do it. If you think it is actually going to be important and point out things that are crucial. To whatever degree I value my own life, as I say, I got lucky being able to come back from all of this, leaving academia and so on. So I would not recommend it to others, but I wouldn't recommend that people not do it. That's a, sometime when we get together again, Shri, you and I have to sort of discuss that one. That is not an easy question. Sorry, I punted.
No, no, you didn't. And thank you. And yes, we will. Thank you so much for this wonderfully inspiring talk again. In the interest of time, I'm closing the recording.